Deep in the heart of our galaxy lies a monster. A place where gravity is so strong, not even light can escape.
Imagine shining a light into a hole, but the light never comes out. It just disappears forever. But what exactly is a black hole? Is it a tunnel, a vacuum cleaner, or just a giant ball of nothing? To understand the whole, we have to look at the life of a star. Every star is a ticking time bomb. For billions of years, a star is a tug of war between the heat pushing out and gravity pulling in.
When a massive star runs out of fuel, gravity wins. The star collapses in on itself in a fraction of a second.
All that mass, millions of times the weight of our sun, is crushed into a single point called a singularity.
This point has infinite density. It warps the very fabric of space and time around it, like a heavy bowling ball on a trampoline. The edge of this trap is called the event horizon. It's the point of no return. Once you cross this line, you'd need to travel faster than the speed of light to get back. And physics says, that's impossible. Even light, the fastest thing in the universe, gets trapped. It orbits the black hole in a circle, caught in a gravitational cage it can never leave. Because no light escapes, we can't actually see a black hole. We only see its shadow, a dark silhouette outlined by the glowing gas swirling around it. Think of it as a cosmic magnet. While light usually travels in straight lines, a black hole is so heavy it literally grabs those rays and pulls them off course. This isn't just a strong pull, it's the ultimate gravity. At this scale, the laws of physics we know on Earth simply break down and stop making sense. At the very center lies the singularity, a point where an entire star's worth of matter is crushed into a space. If you fell in, you'd experience something scientists literally call spaghettification. Gravity pulls so much harder on your feet than your head that you'd stretch out like a long piece of noodle. Time also freaks out. To someone watching from far away, but from your perspective, you'd see the entire future of the universe pass by in an instant. Stars would be born and die like fireflies in the dark. Eventually, even the biggest black holes will vanish. In the far, far future,
not all black holes are the same. They come in different sizes, from tiny primordial ones no bigger than an atom.
Just like our sun holds the solar system together, these supermassive giants sit at the center of almost every galaxy. Think of them as the universe's most efficient engines. As matter falls in, it heats up and glows, shooting out mass.
By blowing away excess gas and dust, these giants actually regulate the birth of new stars.
Even though we understand their power, black holes remain one of the biggest mysteries in science. They challenge everything we thought we knew about how the universe works. But they don't last forever. Thanks to a process called Hawking radiation, black holes slowly leak energy over trillions of years until they eventually evaporate.
Once the explosion fades, nothing is left. The space that once held the mass of 1,000,000 suns. But not all black holes are created equal. They come in different sizes, from mini ones, the size of a single atom. Right at the center of our very own Milky Way galaxy sits a supermassive giant called Sagittarius A star. It's 4 million times heavy. Black holes aren't just cosmic monsters. They are the anchors that hold galaxies together, sitting at the center of nearly every major galaxy in the universe. They are the universe's ultimate recycling centers, swallowing old stars and gas, then shooting out massive jets of energy that help regulate how fast new stars are born. Are they portals to other dimensions? Movies say yes, but science says you'd likely just become part of the singularity, crushed into your basic atoms. There's also a big debate. Does information truly disappear? Some scientists believe black holes store everything they swallow on their surface, like a giant cosmic hard drive. Even these giants don't last forever. Thanks to something called Hawking radiation, black holes slowly leak energy over trillions.
At the very end of its life, the evaporation speeds up until the black hole releases one final, brilliant flash of energy.
But the biggest ones, they are called supermassive black holes. They can be millions or even billions of times heavier than our sun.
In fact, there is one right at the center of our own Milky Way galaxy. It's called Sagittarius A star, and it's the gravity from this giant.
The good news? The nearest black hole is thousands of light years away. We are perfectly safe. For now.
Space is weird, but that's what makes it beautiful. Keep looking up and stay curious.